Okay, so this problem is an example of precipitation gravimetry. So supposing you have a mixture of Al2O3 or Fe2O3, and that mixture weighs 2.019 grams. When heated under a stream of H2, hydrogen gas, Al2O3 is unchanged, so Al2O3 did not react with the hydrogen gas, but Fe2O3 was converted into metallic iron and water. And then the residue weighs 1.774 grams. So what is the weight percent of Fe2O3 in the original mixture? So which means that we need to find the grams of Fe2O3 all over 2.019 times 100. So this is what we need to find. Okay? So we're told nga ang mixture only contains aluminum oxide or ferric oxide. So you have, if we let X be the moles of Al2O3, and then Y be the mole of ferric oxide na present sa mixture, then that means X mole times the molar mass, that's 101.96 grams per mole. So this is mass. This will give you the mass of Al2O3, diba? Plus the Y mole of, so let's just remove mole. Let's just remove that. Y times 159.69 grams of Fe2O3 per mole. So makancel na ang mole, diba? Because that's already mole. So this will give you the mass of Fe2O3 in the mixture. So ang total aning duha will be equal to 2.019 because this is the mass of the sample. Diba? Now, when heated under a stream of H2, it says nga Al2O3 is unchanged but Fe2O3 is converted to metallic iron. So, meaning, ang Fe2O3 ni-react siya with hydrogen gas na reduce to iron and water. So, we have to balance this equation. So, that's 2Fe and then 3 ka-oxygen and then 6 ka-hydrogen. So, that's 3 hydrogen here. Okay, so the equation is already balanced. So, meaning, ang kining 1.774 grams is the mass of katong Al2O3 nga wala ni this term. It's this term plus ang iron nga na-produce. Diba? So, the 2.019 minus 1.774 is equal to the grams of oxygen, this oxygen, nga nakuha gikan sa Fe2O3. Diba? But we can use that one. We can use this one. But it will be advantageous if we use a solution nga applicable sa bisan unsa nga problem such as this. Kay kini siya, applicable ra siya sa kani nga problem if we use the mass of oxygen. So let's use the solution nga kana applicable sa other pud nga problems. So if we proceed, that means nga kining 1.774, di ba? This the grams of Al2O3 plus the grams of Fe is equal to 1.774. Di ba? So this mass of Al2O3 is equal to X times this one, di ba? This 101, so that's 101.96 X. So this is the mass of Al2O3. So it's just this one, diba? Plus ang mass sa Fe, this mass of Fe is equal to it's related to this one, which is 159. Sorry, the mole, that's mole Fe2O3, diba? That's why mole Fe2O3 times, so let's just do this one, times 1 mole of Fe2O3 has 2 moles of Fe. Diba? Gikan sa gikan ani. Okay? And then, gikan ni siya sa balance equation, and then 1 mole of Fe has molar mass sa Fe is, what's the molar mass of iron? So that's 55.85. So that's 55.85 grams Fe. So makancel na ang mole, makancel niya ang mole. So this is equal to 1.774. Diba? So let's simplify. So kini will be simplified into 101.96 x plus 159.69 y, which is equal to 2.019. Ang kini, masimplify siya as 101.96 x plus, that's 55.85 times 2. 55.85 times 2. That's 111.7. This is 111.7 y, which is equal to 1.774. Now, you now have 2 unknowns and 2 equations. So, you can just use algebra. So, let's use the second equation. So, 101.96x is equal to 1.774 minus 111.7y. Okay? So, this will be equal to 101.96. 101.96. So, makancel na. This will give you x. So, this is the value of x. Diba? That's 101.96 times 1.774 minus 111.7y over 101.96 plus 159, sorry, that's plus 159.69y, which is equal to 2.019. So, makancel na. You will now have 1.774 minus 111.7y plus 159.69y is equal to 2.019. So, now you can solve for y. So, that's just a moment. 159.69 minus 111.7, that's 47.99y is equal to 2.019 minus 1.774. That's 0.245. Okay, so y is equal to 47.99. So y is equal to 0.0051. So this is moles Fe2O3. Okay, so if we convert that to mass Fe2O3, because we need grams, so mole Fe2O3, that's 0.0051 times it's 159.69 grams per mole. So this will give you times 159.69. That's 0.8153 grams of Fe2O3. So Here, you can solve 0.8153 over 2.019 times 100. This gives you a value of divided by 2.019 times 100. That's 40.38% of Fe2O3 is present in the sample. Okay?